So in this video, I want to look at Ksp and precipitation. I think what you've looked at so far with the CK12 has done a pretty good job showing you what kinds of calculations you can do with solubility and Ksp and going back and forth. But one thing that they haven't talked about is this question. A lot of times it will ask you, these two substances are being combined, will a precipitate form? And so this is how you use Ksp to answer that question. And so I've got 4 steps here basically, and then I'll show you an example of how to follow through with that. So the first thing you need to do is look at all the ions that are involved. It's going to give you 2 substances, and so just figure out which ones are going to form something that is either slightly soluble or insoluble. The best thing to do is look for your Ksp values. So these are all going to be double replacement or precipitate reactions, and so just figure out which combination is going to possibly give you something that would precipitate. If it's on the AP exam, a lot of times they will just say the Ksp value for whatever is this. That's a huge clue for what you need to do. Once you do that, then you just have to figure out the molarity of the ions. That's a big step. And you have to watch for a couple of things. Sometimes a substance will form more than one of a certain type of ion in solution. For example, if it's calcium fluoride, that's going to be CaF2, so you're going to get 1 calcium ion and 2 fluoride ions. So figure out how many moles you have, and then figure out the molarity. You're going to have to use the volume. And again, I'll show you this in just a second. And then basically you're going to calculate a Q, a reaction quotient for that Ksp reaction. It's been a little while since you've done that. We'll review that real quickly also. But once you get that, then you just figure out what's going to happen. And so the way those Ksp reactions are written, the solid is always the reactant, the ionized forms or the dissolved form is always the product. And so if you look at Q, you can figure out which way it's going to go. If it shifts back toward the reactants, then you know that you're going to form the solid, you're going to have a precipitate. So here is the practice problem from your textbook. Sorry about my camera here. It's a little wobbly today. So exactly 200 milliliters of 0.004 molar barium chloride are mixed with exactly 600 milliliters of 0.0080 molar potassium sulfate. Will a precipitate form? So I'm going to look at the ions that are involved and decide which one of those might form a precipitate. So that combination is going to be like this: barium chloride plus potassium sulfate, double replacement. It's going to be barium sulfate and potassium chloride. Excuse me. So I'm going to have, of course, 2 of these because I need a balanced equation, just one of them. Which one of these could be your precipitate? Now, you may remember we've talked a little bit about solubility rules, and there are some general guidelines. If you've got a group 1 metal and a halogen, you're not going to have a precipitate. Group 1s never form precipitates. They're always soluble. Barium and sulfate, that seems to be my culprit. So if you're not sure, again, just look at that Ksp chart. And I see Ksp listed there. There is a Ksp, for barium sulfate. And it's 1.1 times 10 to the negative 10. That means barium is only slightly soluble, or pretty much insoluble. It's going to form my precipitate. So the Ksp reaction looks like this. It's kind of reverse. We're looking to see if this reaction happens in this direction, but the reactions are always written for Ksp in this direction. So barium sulfate would dissolve slightly into barium ions and sulfate ions. So that means the Ksp, or the solubility product, is the barium ion concentration to the first power times the sulfate ion concentration. Whoops, I put my 2 in the wrong place. Also to the first power. Sorry about that. That negative 2 goes in there. This is to the first power. Sorry if there's any confusion there. So I said the next thing I need to do is figure out the molarity of the ions. in that solution. So you've done calculations like this before. It's just putting this all together. So I've got a lot of stuff here, and I changed colors to hopefully help you stay on track. So for the barium ions themselves, I'm figuring out the moles. I had 0.0040 moles per liter. That's from the molarity they gave me in the problem. And I had 200 milliliters of it. So I'm just multiplying that by the volume. And that tells me that I have 8.00 times 10 to the negative 4 moles of barium ions. I do the same thing with the sulfate. It was a 0.0080 molar solution, and I had 600 milliliters of it, which of course is 0.6 liters. So I just multiply both of those and get how many moles of barium and how many moles of sulfate that I had. Now, here's where you have to pay attention. These two substances, solutions, have been combined. So I had 200 milliliters of this, 600 milliliters of that. So now I've got 800 milliliters of solution. So I don't stop here with moles. I have to go to molarity. So the moles of barium divided by the total volume now in the solution gives me a molarity for the barium ions. And the same thing for the sulfate ions. The number of moles of sulfate ions divided by the total volume in liters gives me a molarity for the sulfate ions. So now I'm going to take these and calculate Q. I'm going to plug them into this equation, but instead of a K, because I don't know if I'm at equilibrium, I'm going to find out what my Q value is. So Q is equal to the barium ion concentration to the first power times the sulfate ion concentration to the first power. And so Q is 6.0 times 10 to the negative 6th. Now, once I get Q, I have to compare it to my K. In this case, it's a Ksp. The Ksp was 1.1 times 10 to the negative 10. And so I can see that the value of Q is greater than my value for K. So if you think back to when we first talked about Q's and K's, if the Q is bigger, that means the products are bigger, because this is always products over reactants. Here we just don't consider the reactants because they're solid. So if I've got too much product, this reaction is going to shift back toward the reactant side. And the way the Ksp reactions are written, the reactant side is always the solid side. So if this reaction is shifting toward the solid, toward the reactants, it's shifting toward the solid, it's making the solid form. And so that tells you that you are going to get a precipitate from this reaction. Obviously, if Q is less than K, then you're not going to have that shift. You could still dissolve more ions in that. And then if Q is less than K, then no precipitate would form. So I hope that's helpful for you. That's really the last calculation that you'll need, and we'll work on this some more. I hope that's helpful, and I will be talking to you soon.